Welcome. In this video we'll be solving trigonometric equations involving cosine part 2. Let's take a look at our first example. Example 1. Solve the equation given below for theta greater than or equal to 0 and less than 2 pi. Here our equation is cosine of 4 theta is equal to negative 1/2. So the first thing to figure out here is the period of this function. Recall that the period of cosine of theta is equal to 2 pi. So we take the 2 pi and we're going to divide by the absolute value of the coefficient of theta here, which is 4. Now the absolute value of 4 is 4, so we have 2 pi over 4, which after we divide both numerator and denominator by 2 becomes pi over 2. So that's the period of this function. The next thing we're going to do is to introduce a new variable. Let's call that variable alpha. So let alpha be equal to 4 theta. Then this particular equation becomes cosine of alpha is equal to negative 1/2. Now also recall that x is equal to r cosine of theta. And on the unit circle that has a radius of 1, we have x is equal to 1 times cosine of theta, or more precisely x is equal to cosine of theta. Since we're dealing with cosine, which is the same as x, we want the angle corresponding to the x coordinate of negative 1/2. So we look at the unit circle and identified what angle or angles have a y coordinate of negative 1/2. So we know that x is going to be negative 1/2. We come over here and we say, okay, here's one point that has that particular feature, and if we were to reflect that point across the x-axis, we get the other point that represents that feature as well. So notice that the angles will be 2 pi over 3 and 4 pi over 3. So alpha is equal to 2 pi over 3 or 4 pi over 3. So what we're going to do is to actually solve for theta based on those values for alpha. So using the first one, let's say we have using alpha equals 2 pi over 3. Let's solve for theta. Now recall that alpha, it's simply 4 theta. So we're going to substitute in the 4 theta for the alpha here. So we have 4 theta is equal to 2 pi over 3. Now dividing by 4 on both sides, we get that theta is equal to 2 pi over 12. And after we divide both numerator and denominator by 2, we get that theta is simply equal to pi over 6. So that's our first angle, theta. Theta is equal to pi over 6. Now to get the other thetas, what we're going to do is to add the period. So we have the next theta will be pi over 6 plus the period of pi over 2. Now we're going to get the same denominator, so let's multiply this one by 3 over 3. And we get that this is 1 pi plus the 3 pi becomes 4 pi over 6, which after we divide by 2, both numerator and denominator, happens to become 2 pi over 3. So that's a new angle theta here. To get the other theta, we're going to take the 2 pi over 3 and we're going to add the period of 2 pi over, or of pi over 2. So we have 2 pi over 3 plus pi over 2. Now in this case, we need to multiply the first part by 2 over 2 and the second part by 3 over 3. So let's rewrite that one as 2 pi times 2 over 3 times 2 plus 3 pi over 3 times 2. So here you have 4 pi and 3 pi becomes 7 pi, all of it over 6. So that's our new value for theta. Now let's add another period of pi over 2. So we take that the next theta will be 7 pi over 6 plus pi over 2. Now multiplying this one by 3 over 3 to get the same denominator happens to become 7 pi plus 3 pi, which is 10 pi, all over 6. Let's divide both numerator and denominator by 2. So that is 5 pi over 3. So that's another value for theta. Let's see what would happen if we add another pi over 2. So let's take the next angle to be 5 pi over 3 plus pi over 2. Now again, let's write this one as 5 pi times 2 over 3 times 2, so we can get the same denominator, plus pi times 3 over 2 times 3. And notice that you get 5 times 2 is 10, plus 3 gives you 13 pi here over 6. However, notice that this one is already past the 2 pi, which is equal to 12 pi over 6. So we're not going to include there. So far, let's recapitulate. We have that theta could be equal to pi over 6, 2 pi over 3, 5 pi over 3, and 7 pi over 6. So those are our solutions so far. Now, to get the other ones, we're going to use the other value for alpha. And notice that the other value for alpha was equal to 4 pi over 3. So let's use 4 pi over 3 for alpha to get the theta. Now recall that alpha was simply 4 theta, so we replace the alpha with the 4 theta, and we have 4 theta is equal to 4 pi over 3. Now, in order to solve for theta, let's divide both sides by 4. The 4's cancel here, and so in this case as well. So we have that theta is equal to pi over 3. So that's our first angle here. Now, to get the other thetas, let's go ahead and add the period. Now, recall that the period was pi over 2, so we have pi over 3 plus a period of pi over 2. Now, getting the same denominator means that we're going to have a 6 as a denominator, so let's multiply the pi over 3 by the 2 over 2, and let's multiply the pi over 2 by 3 over 3. Now, we have that theta is equal to 2 pi plus 3 pi, which is 5 pi, all of it over 6. So that's our next angle. To obtain the next angle, we are going to take the theta being equal to 5 pi over 6, and let's add the period of pi over 2. Now let me multiply this one by 3 over 3, so we can get the same denominator, and we have 5 pi plus 3 pi becomes 8 pi, all of it over 6. Now let's divide both numerator and denominator by 2, and we get that this becomes 4 pi over 3. In a similar way, we take the next theta to be 4 pi over 3 plus a period of pi over 2. Now, looking for a common denominator, which happens to be 6, we multiply the 4 pi over 3 by a 2 over 2, and the pi over 2 by a 3 over 3. That way we can get that same denominator. So we have here that our theta is going to be 8 pi plus 3 pi, which is 11 pi, all over 6. Now, if we were to add another one, okay, if we were to add another value, we see that we're going to go past beyond the 2 pi. So we're going to stop here with this other value. So based on alpha being 4 pi over 3, we get that the theta will be equal to either pi over 3, 5 pi over 6, 4 pi over 3, or 11 pi over 6. So now, to finish up the problem, we can say, okay, our solutions are theta equal to, let's include the previous 4, pi over 6, 2 pi over 3, 5 pi over 3, 7 pi over 6, pi over 3, 5 pi over 6, 4 pi over 3, and 11 pi over 6. So that concludes this particular video where we were solving trigonometric equations involving cosine part 2. Thank you for watching and have a wonderful day.